a dense, collapsed star spinning 707 times per second, making it one of the fastest spinning neutron stars in the Milky Way galaxy, has shredded and consumed nearly the entire mass of its stellar companion and, in the process, grown into the heaviest neutron star observed to date. Weighing this record-setting neutron star, which tops the charts at 2.35 times the mass of the Sun, helps astronomers understand the weird quantum state of matter inside these dense objects, which, if they get much heavier than that, collapse entirely and disappear as a black hole. We know roughly how matter behaves at nuclear densities, like in the nucleus of a uranium atom, said Alex Filipenko, distinguished professor of astronomy at the University of California, Berkeley. The measurement of the neutron star's mass was possible thanks to the extreme sensitivity of the 10-meter Keck I telescope on Mauna Kea in Hawaii, which was just able to record a spectrum of visible light from the hotly glowing companion star, now reduced to the size of a large gaseous planet. The stars are about 3,000 light-years from Earth in the direction of the constellation Sextans. Discovered in 2017, PSR J09520607 is referred to as a «black widow» pulsar, an analogy to the tendency of female black widow spiders to consume the much smaller male after mating. By combining this measurement with those of several other black widows, we show that neutron stars must reach at least this mass, 2.35 plus or minus 0.17 solar masses, said Romani, who is a professor of physics in Stanford School of Humanities and Sciences and member of the Kavli Institute FO. In turn, this provides some of the strongest constraints on the property of matter at several times the density seen in atomic nuclei. Indeed, many otherwise popular models of dense matter physics are excluded by this result. If 2.35 solar masses is close to the upper limit of neutron stars, the researchers say, then the interior is likely to be a soup of neutrons as well as up and down quarks, the constituents of normal proton. How large can they grow? By spinning up, it now becomes incredibly energized, and a wind of particles starts coming out from the neutron star. That wind then hits the donor star and starts stripping material off, and over time, the donor star's mass decreases to that of a planet, and if even more time passes, it disappears altogether. They weren't all alone to begin with. They had to be in a binary pair, but they gradually evaporated away their companions, and now they're solitary. The pulsar PSR J09520607 and its faint companion star support this origin story for millisecond pulsars. These planet-like objects are the dregs of normal stars which have contributed mass and angular momentum, spinning up their pulsar mates to millisecond periods and increasing their mass in the process, Romani said. In a case of cosmic ingratitude, the Black Widow pulsar, which has devoured a large part of its mate, now heats and evaporates the companion down to planetary masses and perhaps complete annihilation, said Filipenko. In the case of this binary system, the companion star, now only 20 times the mass of Jupiter, is distorted by the mass of the neutron star and tidally locked, similar to the way our Moon is locked in orbit so that we see only one side. By comparing the spectra to that of similar Sun-like stars, they were able to measure the orbital velocity of the companion star and calculate the mass of the neutron star. They're hoping to study more Black Widow pulsars, as well as their cousins, redbacks, named for the Australian equivalent of Black Widow pulsars, which have companions closer to 1/10 the mass of the Sun, and what Romani dubbed Tidarans, where the companion is around 1/100th of a solar m. The male of this species, Tidaran sisiphoides, is about 1% of the female size. We can keep looking for black widows and similar neutron stars that skate even closer to the black hole brink. But if we don't find any, it tightens the argument that 2-3 solar masses is the true limit, beyond which they become black holes, Filipenko said. This is right at the limit of what the Keck telescope can do, so barring fantastic observing conditions, tightening the measurement of PSRJ 09520607 likely awaits the 30-meter telescope era, added Romani. Other co-authors of the APJ Letters paper are UC Berkeley researchers Thomas Brink and Wei-Kong Zheng. The work was supported by the National Aeronautics and Space Administration, 80 NSSC 17K0024, 80 NSSC 17K0502, the Christopher R. Redlich Fund, the TABASGO Foundation, and UC Berkeley's Miller Institute for Basic Research in Science. Roger W. Romani, D. Kandel, Alexei V. Filipenko, Thomas G. Brink, Wei-Kong Zheng. PSRJ 09520607, the fastest and heaviest known galactic neutron star. https://ift. TT 7FHZLDI, accessed July 26, 2022. Thanks for watching. Please subscribe my channel for more videos.